Good day everyone, welcome back to my channel. Today we are looking at trigonometry and we'll be specifically looking at a special triangle known as a right angle triangle. Long ago, when the Egyptians built the pyramids, they needed to use right angle triangles to make sure that the base of the pyramid was a square. Pythagoras was born in Greece and studied for part of his life in Egypt. The Egyptians already knew how to use the relationship between the sides of a right angle triangle, and some historians believe that he learned this relationship while studying in Egypt. Now, for us to be able to understand the concept relating to the right angle triangle, it will be important to devise a triangle sorry, just have the hypotenuse. So what this means in a nutshell, it means that the side of this triangle, this side here, we have a perfect square here. So we have a squared this side with this side. We have b squared this side. And then lastly, the longest side of this triangle. We have c squared. So essentially what this means when we need to unravel certain parts of this triangle, right angle triangle, is to identify that this side being A, the side, all the squares placed on this side of A will be identified as A squared, and all this side, rather the squares placed on the side of B will be identified as B squared, and all the squares placed on the side of C will be identified as C squared. So essentially what this means, it means that our general formula for our Pythagoras theorem says the longest side, which is that side opposite the right angle itself, is actually c squared is equals to a squared plus b squared. Or if a is made a subject of the formula, it will be c squared minus b squared. Or if b is made a subject of the formula, it will be c squared minus a squared. This is key for our understanding in studying trigonometry, especially right angles, triangles. So moving on forward, we need to be able to see how this notion of triangles, right angle triangles, actually applies in solving various problems relating to right angle triangles themselves. For instance, when we look at this concept of Pythagoras, or rather the Pythagoras theorem, it will be important to actually be able to devise a triangle. Rather, let's start with a square. This is our square. Not really a square, but a rectangle. So let's go ahead and devise our rectangle. Now, given this analogy, we should actually be able to identify some key concepts relating to this. So, if I may have to identify this rectangle as A, B, C, and D. Remember now, the longest side is opposite the right angle, which is in this case B. And then this side we have side A, and this side we have side C. Side C is given as 5, and side A is given as 12. To find B, I'm going to use two analogies in case one comes across these two applications in any one of the textbooks or the books or any resource. We're going to say now B squared is equals to A squared plus C squared. Or sometimes you might find something similar to this. AC, okay, there's line AC squared is equals to line BC squared plus line ABC squared. Okay, this is actually generally the same thing. Substitution, by substitution rather, we can just simply say B squared, okay, this is what we want to find, is equals to A squared, in this case is 12 squared plus C squared, we have 5 raised to the second power. B squared is equals to 12 times 12, it gives us 12 times 12 gives us 144 plus 25. Okay, so similarly on this side I can do the same application. We know that A squared, AC rather, AC squared is equals to BC, or rather side BC is equals to 12 squared plus side AB. By substitution we have 5 squared AC squared is equals to 12 times 12 gives us 144 plus 25. Okay, this is generally the same thing. So now by solving this further, I'm going to have to use the space because I'm running out of space now. Allow me to erase, sorry, we just erase a fraction of this, not the whole diagram. And then I just have to erase this part here. Okay, we still have our line, our hypotenuse line. A is the longest line. So in this case, and then B still remains. This is what we want to find. Now, moving on forward, I'm gonna take these simultaneously to solve for b squared. So this time I have b squared is equals to b squared is equals to 144. So we have 144 plus 25 gives us 169. So when you square these on both sides, the square will fall off and we'll be remaining with b is equals to 13. So in a nutshell, b is equals to 13. So we have 13 here. Similarly, if you want to use this approach, if one wants to use this approach, it is equally viable to say remember we have 13 here, is to say AC squared is equals to 144 plus 25 gives us 169. Okay, because remember now here we had AC squared is equals to at BC squared, this one here, BC, side BC squared plus AB squared gives us 169. And if you square this on both sides, you will get B as equals to 13, or you will get AC, or other side AC equals to 13, which is the side here between this angle and that angle there. Now let's move on forward to finding other missing values, or other sides of these angles, of these triangles. So now let's look at another example. So suppose now you are given this triangle. Now this triangle, you have a right angle. They're given angles A, B, C. This side is A, and it's unknown. Side B is given 17, and side C is given as 15. To calculate this, we're going to just simply say, we're going to make A now the subject of the formula. So A squared is equals to B squared minus, because B is the longest side of the angle of this triangle, which is the hypotenuse, minus C squared. A squared, we don't know what it is, so we could keep it or maintain it as the subject of the formula. B squared is equals to 17 raised to the second power minus C in this case is 15 also raised to the second power. So we have a squared is equals to, so 17 raised to the second power, we have 289 minus 15 raised to the second power, we have 225. A squared is equals to, so we have 289 minus 225, we have 64. So if you square this on both sides, A is equals to 8. So that's our final answer, which means A in this case is equals to 8. Let's look at other more exciting problems to solve. So let's look at number 1. Let's look at number 1 now. Number 1 goes like this. It says now, in number 1 to 6, we need to find the values of C, which are the unknown sites. So let's start with number 1. So given the triangle, this triangle here, given this triangle, we have, we don't know what C is. We know that this side we can identify it as A, which is 12, and this side we can identify as B, which is 5 units. Since we have C, so we can just simply say X in this case. So it's actually A, which is 12, and Y is equals to B, and which is 5 in this case. So calculating this, we're gonna just simply say, because since now C is the longer side of this right angle triangle, so I'm gonna go say C squared is equals to A squared plus B squared. Okay, so this actually is the summation of that and that squared. So that's what it actually means. So C squared is equals to 12 raised to the second power plus 5 raised to the second power. C squared is equals to 12 times 12 gives us 144 plus 25. C squared is equals to, let's go ahead and punch this in our calculators, and we get 169. 169. If you square this on both sides, C is equals to, make sure that your answers are correct, it's 13. So this side there is 13. Let's look at number B, or sorry, number 2. Let's go and find other sides of these triangles. So this time we're given a triangle that looks like this. Okay. So still have our right angle there. Here we have 15, we have C, and we have 12. Now to calculate this is to simply say, now okay, now since now C is the longer side, I'm gonna make it the subject of the formula, which is now C in this case, C squared is equals to, let's call this side A, and and let's call this side B. So we're going to have a squared plus b squared. C squared is equals to a squared is 15 raised to the second power plus b squared is equals to 12 raised to the second power. C squared is equals to 15 times 15. You can go ahead, punch this on the calculator. We get that it's 225 plus 12 times 12. 12 times 12 gives us 144. C squared is equals to 144 plus 225 gives us 369. When we square this, the square will fall off. Therefore, C remains. C is equals to 19,21. Rounded off to 2 decimal places. So we have 19,21. That's the value of C. Okay, let's move on to other examples. So this is example 3. This is example 3. Now example 3, we are given this triangle. Now on this triangle we are given lines like this, and then we given C, and only one side is given. I'll call the side A. I'll call the side B because we have C already this side, which is unknown in this case. Now these lines here, these lines, there are implications on these lines. They are telling us that these sides are equal. In other words, if A is equals to 6, B is also equals to 6. So by calculation, we're going to say C squared is equals to A squared plus B squared. C squared is equals to A squared, in this case is 6 raised to the second power plus 6 raised to the second power. C squared is equals to 36 plus 36. C squared is equals to, now 36 plus 36 gives us 72. So we have 72. If you square this on both sides, the square will fall off. And the square root of 72 gives us 8,49. And that's our final answer. This gives us 8,49. That's a value of C. Okay, let's look at 2 more. No, let's look at, this is number 3. Let's look at 7 more. Let's look at 7 more. So in this case, it's just, now we have number 4 in this case. Number 4, for question number 4, we're given this triangle. We're given this triangle. Call this A. It's equals to 6. No, we're given 4. Sorry, we're given actually 4 here. C is unknown. C is unknown, and then B is 3,5. Now, C is the longest side of this triangle, so you have C squared is equals to A squared plus B squared. C squared is equals to 4 raised to the second power plus 3, 5 raised to the second power. C squared is equals to 4 times 4 is equals to 16 plus, and then we have 3, 5 raised to the second power. 3, 5 raised to the second power, we have 12, 25. By calculations, 16 plus 12, 25, we get 28, 25. When you square this on both sides, you can say therefore C is equals to 5, 3, 2. That's our final answer. We have 5, 3, 2. Okay, let's look at other more examples, other more exciting examples relating to trigonometry. So let's look at example number 5. Okay, now example number 5, we're given this triangle. These are all right angle triangles. So perpendicular, the this hypotenuously. So we have given 10 this side, given C, which is unknown, and we're given 6. You can go ahead and say this is A, this is B, and then to find the value of C, you can just simply say C squared is equals to A squared plus B squared. C squared is equals to A squared is 10 times 10 plus B squared. In this case, we have 6 squared. C squared is equals to 10 times 10 now is 100 plus 6 times 6 gives us 36. In fact, we should, because 100 in this case is the longest side, so C squared should be our difference. So technically what we need to do is to say A squared is equals to B squared plus C squared. Yeah, that's the logic, because of this side being the longest side. So 10 squared is equals to B squared. Now here we have 6 squared plus C squared. We don't know what C is, so we have 10 squared minus 6 squared is equals to C squared. 100 minus 36 is equals to C squared. So 100 minus 36 gives us 64. So if you square this on both sides, C then becomes 8. So we have 8 units there. This side must always be the longest, or rather the biggest side compared to these two sides here. Hence, this application was not going to be applicable. Let's move on to number 6. number 6. So let's look at number 6. This time we're given this triangle. This time we're given this triangle. We have 6, 9, given 8, and we have C. And C in this case is unknown. You can call this A. You can call this, it's fair enough to call this B. So this time we're given B, which is 8, given A, which is 6, 9, and we need to find C. Now, our original formula of Pythagoras is B squared is equals to A squared plus C squared. Remember, we want to find the C squared, so we can just simply substitute. So we are given B, as in this case is 8, so we're going to have B squared minus A squared, because A is positive. If you move over the equal sign to join B squared, it becomes negative A squared. It's equals to C squared. That's the logic. Now, B squared is equals to 8 squared minus A squared. We have 6, 9 squared is equals to C squared. Moving forward, to calculate that, we know that 8 times 8 gives us 64 minus 6, 9 times 6, 9 gives us 47,61, which is equals to C squared. 64 minus 47,61 gives us 16,39, which is equals to C squared. Now, to square both sides, C, the square will fall off, and then remain with C, and the square root of 16,39 is equals to 4,05. So we have 4,05 here. Okay. Just by observation, again, whenever you work with calculate the sides of right angle triangles, always keep heed of these sides. Okay, it is very important to especially look at this side here. It should be the longest side or the biggest value compared to these two sides here. A, in this case, A and C. Let's look at problem number 7. Problem number 7 is more of an animation. So in this case, I'm propelled to actually draw some illustrations. Okay, now this time we have question number 7, and we are given something that looks like this, and right in the middle, it's actually right, it's a triangle joining there, and another triangle joining there. So we have something that looks like a roof. And a rectangle. Okay, now in this case, we are given some certain parameters with regards to this. So we are told that this side here is equals to 3 meters. And this side is equals to that side as well, equivalent. And the height is equals to 1 meter. The height of this roof is equals to 1 meter. To calculate, they ask us to find the length of the corrugated iron needed to build the roof. So let me highlight this roofing using a highlighted color, probably using that color there. So this will be our roof. That's our roof, orange color, and this is part of our roof as well, this orange color. So let's go ahead and find the length. So let's first find some parameters. So we have here, we can have C. We don't know what C is. This is A and this is B. So we know that C squared is equals to A squared plus B squared. Remember, C squared is the total sum of A squared and B squared. So C squared is equals to A squared in this case is 3 squared plus B squared is 1 squared. C squared is equals to 3 times 3 gives us 9 plus 1. C squared gives us 10. If you square this on both sides, C then becomes, let's look at what the square root of 10 is. Is equals to 3,16. So this is 3,16. So we are told that this side and that side are equal. So technically this will be also be 3 meters. If that is 3 meters, C on this side, I'll call the C1 down. This will be C2. C2, to find C2. To find C2, remember now this is now C2. C2, C2, let's just say 2C, 2 squared is equals to, we have now A, called A1, B1, this is now B1 now, B2, let's call this B2, and B2, A2. So we have A2 squared plus B2 squared. Just to annotate these variables, so we know that C2 squared, which is this part here, the side bit, is equals to A2 squared. In this case, we know that is 3. So we have 3 squared plus B2 squared, we have 1 squared. So C2 squared, still unknown, still have 9 plus 1. C2 squared is equals to 10. If you square both sides, C2 will remain. Remember, this was C1, this is now C2. This was C1 here, this is now C2 here. So C2 is equals to 3,16. 3,16. Therefore, C C2 plus C1 is equals to C2, we found that it was 3,16 plus C1 was also 3,16. This one here is equals to, if you add 3,16 plus 3,16, we get 6,32. That's the total length of this roofing. So in other words, from here to there, to there, and to there. In other words, use a different color. From A, B, C. There's a total length of this roofing. It is needed. Now let's move ahead and find other sides. Okay, let's look at number 8 in this case. Now number 8. Number 8, we are given a gate. Okay, suppose now this is the gate that you are given. So we're just going to have simple schematic representation of the gate. Okay, actually have the actual gate now. This is actually part of the gate. So this is now the actual gate. It is a rectangle. Now we have a diagonal. We have a diagonal. Now this diagonal, the length of this diagonal is 2,5 meters. Okay. And then the height of the gate is 1,5 meters. Now, to be able to find the other sides, or rather, yes, the other sides, we know that this, you can call this A, the side here. This you can call this C, and then this side you can call this B. B is unknown. So in this case, to find C, we're going to actually start making B the subject of the formula to use C as now to find the difference between C and A. So you're going to say now B squared is equals to C squared minus A squared. B squared is equals to C squared, we have 2,5 squared minus A squared is 1,5 squared. B squared is equals to, so here we have 2,5 squared, we have 6,25 minus 1,5 squared, we have 2,25. B squared is equals to, so we have 6,25 minus 2,25, we have just simply 4. And when you square both sides, the square will fall off, you remain with B. So B will be then B, just simply 2. So that's our final answer. So B is equals to 2. If that side is parallel to that side, so we can call this B1, which is also 2. And we have A1 that side, and we have A2 to this side. This is opposite, it's also 1,5 meters. It's just basically the general application of this. Let's look at number 9. Let's look at number 9. Now number 9, for number 9, we are given a wall. So this is our wall. Okay, this is our wall. These are just special effects. This is our wall. Now we have our wall. Uh-oh. Sorry, I'm gonna have to shift this back to the original side. There you go. So we have our wall. Okay, that's our wall. Now we are told that there is a step ladder that is inclined onto the wall. So that's our step ladder. Okay, so let's have our step ladder. Just try and justify my application by means of sketches so that we are all on par with this logic. So I have my staircase now. It's a step ladder. Okay, it's not the best drawing, but I tried. Now, we are told now this time that the height of this wall is 4 meters. So I'm going to write 4 meters. That's the height, meaning that from here up to the foot of this wall, we have the length of 4 meters up to here. So that from there to the top to bottom, it's 4 meters. Now, similarly, we should also acknowledge that this is the ground, and then the height, or rather the hypotenuse, the inclination, the height of this step ladder is 5 meters. So now we are asked to find out how far is the foot of the step ladder from the base of the wall. So in other words, how far is it from here to there? So we can call this A. We don't know what A is. We can just simply say this is C, and we know that this is B, because we know we're given C. Now, to find this, or rather calculate this, we'll just simply say, now we want to find the distance between the step ladder and the foot of the wall. Foot of the step ladder and the foot of the wall. So now in this case, just leave a small space here so I can be able to slot in my answer once I've calculated the answer up. So in this case, I'll just say okay. Now a squared is equals to c squared minus b squared. A squared, that's what I want to find. C squared, we have is equals to 5 squared minus b squared. In this case, we have 4 squared. A squared is equals to 5 times 5 gives us 25 minus 16. A squared is equals to 25 minus 16 gives us 9. So if you square on both sides, the square will fall off, and then we have the square root of 9 is equals to 3. So that A there, distance is 3 meters. Okay, that's what the application looks like. So now finally, we are now asked to find out how long is the wire support holding the fence pole in the ground. So let's go ahead and determine that narration. It's the final insert. Okay, so now let's look. So this time we are given this pole. In fact, we are given this pole. Okay, let me just see a tower. So we're given a tower there. And then this is the ground. Okay. And then there are support struts according to this analogy here. We have support struts. Now we are told
it's 21 hours.
We are told that the height of this tower here, from there to the foot, from the top to the foot of this is 2 meters. Okay, and I'm also told that the distance from the foot of the tower to the foot of the strut is 1 meter. That's the distance from there to there. So what we need to find is the length of this tower, of this support strut, or of the wire itself. This length here. That's what we are asked to determine. So I'll call this side A, I'll call this side B, and I'll call this side C. So C, it follows that C squared is equals to A squared plus B squared. Now, we know that C squared is the longest side, so we first need to plug in the values. Okay, first need to plug in the values. So by plugging in the values, we have C squared is equals to A squared, in this case is 1 raised to the second power, plus B squared is 2 raised to the second power. So C squared is equals to 1 squared, we have 1 times 1 equals to 1, 2 times 2 equals to 4, C squared is equals to, so 1 plus 4 gives us 5. So what this means is that the square root of, if you square this rather, both sides, and then 1 plus 4 gives us 5. Square this on both sides, remember C. And the square root of 5 gives us 2,24. And that is the final answer. So essentially what it means now, what this means now, it means that we found this value here. C2, we found C to be 2,24 as the length of the wire that support the holding fence pole in the ground. Okay, thank you for watching. I really enjoyed working through these examples and some of these activities. Please like, share, and subscribe to my channel so I can create more content. Thank you for watching. Until next time, goodbye.